In problems 7 through 12, we want to use a graphing calculator approach similar to the way we did to evaluate limits numerically, except that now we're evaluating at infinity. So instead of getting closer and closer to a particular number from the left and the right, we just want to use larger and larger values as we go out to positive infinity or negative infinity. We'll only do one of the sides there. So let's take a look at what this might mean. I open up the graphing calculator, go into y equals, and we'll put in this function 4x plus 3 over 2x minus 1. Remembering to put parentheses around the numerator and around the denominator. You really have to be careful with that. Alright, so we're going to do the same type of thing. We're going to go out to second, table set, make sure that independent is set to ask, go out to the table itself, and now we're going to put in values 10, 100, well 10 to the 0 would be 1, so we'll skip over that. 100, 1,000, 100,000, 10,000, 100,000, and you can see that we're heading for 2. If we put one more out there to cover up that 0.001, then that would be 10 million. And you can see that we're approaching a horizontal asymptote of 2. No matter how large the number gets, it won't go past 2. It'll get closer and closer to 2. Once again, that 2 is not a real 2. It's really 2.00025, etc. Now again, how do we know this? We can do this quite easily by just looking at the leading terms, 4x over 2x. Since they're the same degree, we just divide 4 by 2 and get 2. Alright, let's put the next one in. So we have negative 6x divided by square root of 4x squared plus 5. And in this case we don't need parentheses around the numerator since there's only one term there, and the denominator only has the radical expression. So that's all we need there. We go into table, and since our values are already in there, we can see that as we go out larger and larger values, we're approaching negative 3. Now we're going to get into this particular form of limit at infinity when you have an x in the numerator and you have a square root of x squared in the denominator. For right now, if you were to just take the square root, when you're working with positive numbers, it's fine. You take the square root of 4x squared and you get 2x. And negative 6x over 2x would give you negative 3. Sorry, it's negative 3. And that's how that works. We'll go on to the next one now. Number 11. We'll put in the function 5 minus and then 1 divided by, and we'll definitely want parentheses around x squared plus 1. And we'll go in and take a look at our function. Again, the x values are already in there. We can see that this is approaching a limit of 5. How might we explain that? Well, again, because in the fractional part, the denominator has a larger degree than the numerator. As x goes to infinity, that's basically going to become 0, and 5 minus 0 is just 5. So this is a way of finding limits using our graphing calculator, limits at infinity, that is, using our graphing calculator. Similar but very different than the way we found limits at a specific x value. And we'll go on to the next set of problems.